Good morning, sir. Good morning, everyone. Welcome to the
ಕೇಸ್ ಇದಾಗಿದ್ರಲ್ಲ ಕೇಸ್ ಅವಾಗ.
Good morning, sir. I request all participants to mute both audio and video. Requesting all to mute both audio and video. We'll start with the session. Looks there is some error. Someone started presenting in between.
yes. Good morning, everyone. Good morning, sir.
Good morning, sir.
Welcome to Start Matla.
Yes, sir, you can start, sir.
Okay, sir. So let me on my video. So welcome to the third day of the session on FOSS, and we'll be discussing Python today too. And today the agenda is simple calculations, polynomial, matrices, and numerical methods. So basically, I'll start with addition. I'll start with addition, subtraction, multiplication, division, and some math. Yes, sir.
Once again, someone presented in between. I think your presentation is not answered now. After your presentation, someone else has done something.
Okay.
Please start with the presentation.
Yeah. Amen. Now is it visible, sir? No, someone else is presenting now. Bappa Ghosh. Bappa Ghosh, please switch off your presentation. Yeah, so I think now I am visible.
Yes,
so this is visible. No contents are visible. Okay. So as I was telling, we'll do simple calculation. Yes, sir.
Full screen, sir. You can make it full screen.
Full screen. Yeah. Yes.
Okay. Thank you, sir. Thank you.
Yeah. So addition, subtraction, multiplication, division, these are simple functions. Will not go in detail, or we need not do anything on Python on that, because it's just a function directly callable and we can use them. We will call some mathematical functions and learn some simple programming concepts using math functions. Then we'll go to polynomials, wherein we'll deal with operations on polynomials. So how to declare a variable x, how to declare a variable y, and then how to find roots of linear equation, quadratic equation, cubic equation, and quartic polynomials. Basically, we'll also try to We'll also try to deal with fifth order polynomial, and we'll see that we'll not be able to find the root of fifth order polynomial because quintic polynomials are not solvable using radicals. That we know. Now, the third aspect will be the matrices. In matrices, we learn about operations, addition and multiplication, inverse, adjoint, trace, determinant, eigenvalue, eigenvector, and solution to systems of equations. Then we'll go to numerical methods. What we could not do, like the quintic polynomial which we couldn't solve, transcendental polynomial which we couldn't solve, we will solve it using bisection, secant, and regular falsy Newton absence method. Then we will do linear algebra. We will do solution to system of equations using Gauss-Seidel-Jacobi and find the largest eigenvalue using power method. And finally, go to interpolation. Today, we stop with cubic spline interpolation. So let me begin with the simple calculations. So we have opened the spider. As usual, you need to open the spider, and then I've already opened the simple calculation dot file.
Jupyter spider one more questions idella.
So here I've just written some number 260 plus 340 into 2 minus 300 by 4. So remaining things I'll just comment so that we can execute this. So if any sort of addition, multiplication, division and subtraction is seen here. So all together, you should get some value here. 260 plus 340 would give you 600. 600 into 2 would give you 1200. 1200 minus 300 would give you 900. 900 by 4 would give you 225. Let us check whether we get that answer. Simple, it should come. Yeah. Therefore, we have got here in the Python console, if you see, 225.0 is the solution. Then similarly, if I give print 2%5. Okay, so I think this should give us the reminder when 2 divides 5. So if you see that 2 is the reminder, 2 is the quotient, because 2 2s are 4 and remainder is 1. So it gives you, then you can round off the value. So I have mentioned that somewhere down. So we'll go to other functions of math. So we see here. Okay, so here we import the functions. We first import math. Then from math we import sine, cos, tan, sine inverse, cos inverse, tan inverse, secant inverse, secant inverse, cosecant, and cot inverse, cot are not there, but you can write them as reciprocal identities, 1 by sine, 1 by cos, 1 by tan respectively. Then tan hyperbolic, sine hyperbolic, and cos hyperbolic are there. Then I have not called pi. We can actually call pi also. We can import pi, but instead of doing that, I have written math.pi, which is also declarable. So x is equal to math.pi by 4. That's some value which I have considered. Y is equal to 3 pi by 4. So you know that compound angle formulas are all true. So I have written a small statement, program if and for loop. So if you have a if statement, then the condition is given in this way. So I have taken a compound angle formula, sin x plus y is equal to, so conditional, I am declaring it as if it is equal, so double equals have to be used. So sin x into cos y plus cos x into sin y. We know that it is true, but just for the sake of knowing whether it is computable or not, so I'm declaring it as a if statement, and then we close here, and instead of or instead of some other bracket or a flower bracket and so on, we close it by a colon, and then we indent. This is very important. We need to indent. What happens in spider is once you put the colon, or once you just complete your if statement, if you enter, okay, if you put the colon and enter, it comes back to this position, or you need to give a indentation in order to you need to give an indentation in order for that command to execute. So I've written print compound angle formula is valid and print the value of x, y and sin x plus y. So let us see whether it works or not. Okay. Now we have just declared this much, so let us see whether this works. So it has taken sin x plus y is not equal to. So if you say if it is not equal, compound angle formula is not. So if I give this, it should take sin x plus y is equal to sin x cos y plus cos x sin y, and it should give compound angle formula is valid. Now let us see why compound angle formula is not valid. So if I see, if I just give this not equal to is exclamatory and not equal to. Suppose I give this and I say compound angle formula is not true. Okay. It is true, but I'll tell you why it is not coming true in case if this statement executes. Yeah. So you can see here, x value is 0.785 because of the truncation error in Python and because of the number of digits which it takes and sign values. Therefore, it has not gone to 0. It has gone to 10 to the power minus 60. Now, instead of giving sin x plus y is equal to sin x cos y plus cos x sin y, suppose I give round off sin x plus y, and if this rounded value is equal to rounded value of sin x plus cos y, sin x cos y into cos x sin y, then I think it should come. Let's check here. Yeah, it has come, but the statement I have not changed. Compound angle is valid, I have to say. Is valid, and I should get x y and x plus y, sin x plus y value. So control S function f5. The compound angle formula is valid. Similarly, we know that cos hx square plus minus sin h square is equal to 1. So let us verify that. Again, if statement. Then fine, close this. Similarly, we have used exponential of log y plus x, comma matching. That means it's a natural log, which I am considering. So exponential of log y plus x should be equal to x plus y. We know that, or y plus x. So we'll see whether this formula is true or not. We'll comment this. In Python programming, what is very important is the indentation. Once you give the indentation, for every condition what you declare, you need to give an indentation of 5 spaces, which in Spider is taken directly. So you don't have to worry if you're writing it in Spider or in Anaconda or in Jupyter. But if you're writing it in VI or in NEdit or gedit, you need to be careful. You need to give the indentations. So that is very important. So formula is true. The first one came. Second one, I think, again, I'll have to check. Which one has come? Let us check. Okay. This is not come. Cos x square minus sin x square is equal to 1. We know that the formula is true, but it has not come because, again, of the round of truncation error in Python. But the next one has come directly. I'll give round of this if it is equal to 1. Yeah, formula is true. So like that, we can perform if statements. Now we'll go to for statement. We saw that exponential of log x plus y is equal to x plus y, and we got formula true. Let us see the log statement. Now let us see the for statement, that is, sorry. Okay. Here, okay, so we are executing for I in range. Note that I have not used any other library. I have just used math library, and in math library we have these general commands which we have, and the expressions and functions which we have written here. So we can use them, and constants also can be called from math library, like pi, exponential function, exponential number, and so on. So math.e is also there. So here I have written some questions like some identities, Pythagorean identity, and sin I by cos I is not equal to tan I. I have just given it like that, so it should give a print error if it is true. Then all formulas correct. If it is not true, then all formulas must be correct. That's what we are seeing. So when we declare for, again we need to give an indentation, and indentation for f is also given. And else if we are giving, we need to come out of if loop and then give else if. And else statement also similarly, come out of if loop and then give else statement. So let us see whether it works. Yeah. Sign is not fine. Oh, okay. This is the condition. Yeah. I need to give it from this line. Okay, now it works. Yeah, so you can see here it has given. I gave a print statement for every condition. So if has given some 3 print statements, then the next one has given 3. But no, anywhere we didn't get error because I've used the correct commands. Or sin by cos is equal to tan. We know that it is true, so therefore we didn't get the error there. So rest of cases we have got this. So this is simple programming. We use the same technique for all the programming in numerical methods. That is, we use for and if statements and then do the programming. Any other thing if we use, I just tell it right away, like matrices or solve commands or any other command which we'll see while doing the next one. So shall we go to the next one? I think we can go to the polynomial simplification. So here I have used SymPy. So for numerical calculations or numerical methods, we'll use NumPy. So simple calculations, we learned about library math. For polynomial calculations, we learn the library SymPy. So here, when we call SymPy, SymPy is symbolic Python. You can see this. And from SymPy, we import symbol for declaring the variables x, y, z, and so on. There is another command we can give sims from symbol import sims abc. That also is true, and we can give any variable without declaring them as symbol x, symbol y, symbol z, and so on. So here I have used pprint. Pprint means pretty print. I'll show you what is the utility of it. You will get the solution exactly how you write in your notebook. So that is a pretty print command advantage. So here I have given x, y, z. The remaining equations can be given directly. So here the equation is x square plus 2x plus 1. So I need to solve them. So you need to solve them. To solve them, we can give print solve. Solve I have called there. Solve I have called in SymPy. So solve y1 comma. We need to solve it for x. Okay. Then the remaining equations we'll see later. Whenever we start with the comment, we need to end the comment also. Otherwise, it will show a syntax error. So we have to be careful of such things. So the equation is x square plus 2x plus 1. So we know the solution x is equal to minus 1. So let us check whether we get that solution. Yeah. So we got minus 1 in 12, if you see. Let me clear this. The command for clearing this is CLEAR with a bracket open and close. To clear the screen. Then we see the cubic equation now. 2x, 3x cube plus 2x plus 3. Let me use this. I'll remove the comment here and I'll put the comment there. So y is equal to 3x cube plus 2x plus 3. I don't know the solution of this. It is a cubic equation. So let us check. Print I have given. So it gives a solution like this. Square root of 761 by 2, power 1 by 3 by 3 and so on. So we don't know how to look at it. So if I give p print, let us see what we get. Pretty print if I give. Then in the usual math way. So you see the solution 2 divided by 3 into minus half minus root 3I by 2 into 3 root 27 by 2 plus root 761 by 2 minus the remaining thing. So the entire solution is given in the math way. Similarly, the quadratic equation, let us check for the quadratic equation what we get. It's only one command for solving them. That is solve. Solve command will solve a polynomial equation. It's also a linear system of linear equations also, provided we give what variable we need to solve for. So here p print solve y1x again. You get huge solutions like this. So one is a one uses Ferrari's method, another one uses Cardano's method, and for simple quadratic equation, it is the Sridhara's formula which will be used. And if I give a quintic polynomial, suppose I give 3x to the power 5, let us see whether it solves it or not, for the sake of knowing whether it solves. See, C root of, so it doesn't solve. It gives there are 5 roots, 0, 1, 2, 3, 4, 5, but they are not the roots, they are just the numbering indexes of the roots. So 0 to 4 roots, that means 5 roots are there for this particular equation, which is known to us. We know that by theorem of fundamental theorem of algebra, we know that for any nth order equation, we should have at most n roots. So that's what it has given. So in order to solve them, we'll use bisection, regular falsy, secant, and Newton absence method. We'll see how to solve it using those methods. Now, does it solve transcendental equation? Maybe. Let us check. So I'll close this. Comment this. So here I've taken system of linear equations. A is equal to x plus y plus z minus 2. B is equal to x minus y minus z minus 1. C is equal to x plus y minus z minus 3. So we are solving for A, B, C and x, y, z. So that means A is equal to 0, B is equal to 0, C is equal to 0, gives us an equation x plus y plus z is equal to 2, x minus y minus z is equal to 1, x plus y minus z is equal to 3. When we solve it, we are supposed to get a solution which is simple. I think we can just get that. Okay. Yeah. See, I didn't remove the comment, so showing error. Let me clear the screen. We'll get the solution in the fresh page. Okay, this is. Yeah, here we have x is equal to 3 by 2, y is equal to 1, z is equal to minus half. as I told, it's all system of linear equations. So P print Q has given the solution as x is equal to 3 by 2, y is equal to 1, z is equal to minus half. Then similarly, b1 comma x, b1 is x to the power 5 minus 4x cube plus 2. This is one equation which I tried, but again we didn't get the solution for it. As I told, it doesn't solve quintic polynomials. Then let us take A1. A1 is equal to exponential. So we have taken B1 is equal to e power x square plus e power 2x, that is B1 is equal to e power 2x plus e power x plus 4. Let us see whether it solves this equation or not. And so for that I need to write this one, I need to close. C1 is equal to solve B1 comma x. So P print C1. So function f by. So what the solution is log minus half minus root 15I by 2 and log minus half plus root 15I by 2. So some of the equations it does solve because it is like e power x square. So e power x square plus x plus 4. So it is something like that. So you can solve it. If you see other problem, like it's a nonlinear equation here. B1 is equal to e power 2x plus 2 e power x into x plus 3x minus 4. Let us see whether it solves this. Okay. Yeah, it doesn't solve. No algorithms are implemented to solve equation 2x e power x plus 3x plus e power 2x minus 4. So for that we need to write solutions using bisection or Newton-Raphson's or any other method which we have. So let us see that in the next session. Next we'll go to matrices.
Madhukar sir.
Yes, sir.
Someone presented in between. Your PPT is again off, sir. Please.
1 minute, sir. I'll just. Thank you, sir. Yeah. So I think till here everything was there.
Yes, sir. Yes, sir. Correct, sir.
So I'll go to matrices or I was just showing the nonlinear equation, transcendental equation cannot be solved using direct method, using SymPy. So we need to go to numerical techniques. So that's the we'll go to numerical technique in the next stage. After doing matrices, we'll go to numerical methods. So let us go to matrices. Now matrices can be accessed through SymPy and NumPy. We need to be very careful. SymPy matrix has a capital N. Okay, and NumPy matrix has a small m. That's the difference. So NumPy matrix has a small m. Now if you are using Spider, the advantage is you get all the variables and other things if you just keep the cursor on the thing. So transpose, trace, all those things can be called from NumPy. And NumPy has another module called linear algebra, wherein inverse, determinant, eigenvalue, solution to the matrix equation Ax is equal to B, single value decomposition, norm of a matrix, and matrix rank can be computed. Okay, so I'll show you everything in detail. So before that, we'll do SymPy calculations. So in SymPy, as we know, it is symbolic calculation. So we need to call the symbol x is equal to symbol x, y is equal to symbol y. Then the matrix in terms of symbols I have given x 2y square, y 2x. So I will print z plus z. Let's see, it should compute. Now I just remove this do it statement. I'll tell you why we use do it also. Okay. So two things I'm printing. One is determinant of z star z. So z star z will be a 2 cross 2 matrix again because z is a 2 cross 2 matrix. So determinant of that should be printed and z plus z should be printed.
Madhukar, sir.
Yes, sir. Again.
PPT, sir. Again. Manjunath sir.
Manjunath. Yeah. Yes. Now it came, sir. So shall I continue?
Yes, I can continue. I can continue.
Yeah. So I just run this command. The command is for z plus z. So whether the symbolic Python adds the thing. So it should add. So we'll just see whether it does. Yes. So we got 2x 4y square, 2y 4x. And if you see determinant of z star z, it has computed z star z, but it has not found the determinant. Okay. So that means the command determinant of z star z will give only the symbol determinant z star z. So in order to execute that, we need to specifically type do it. Okay, this has to be done even for differentiation and integration. Also, we'll see that in the tomorrow's session. How to find limits, especially limits. Also, you'll have to give do it command. Differentiation you have to give do it command and so on. So determinant also you need to give do it command in order to Python to execute the command. Okay. So let us see what happens. Yeah, now it has computed. See, if you see here, x square plus 2y cube into 4x square plus 2y cube minus 18x square y cube. That's the solution determinant which we know for 2 cross 2 matrix. So it has computed. Now suppose you want a solution for this x and y. What is the solution for x and y? If you equate it to 0, obviously it will be 0 itself. So let me change the value to x minus 1 and 2y square minus 4 and y minus 2 and 2x minus 2 minus 4. Suppose some solution y minus 2 also equal to 0 we are writing. So let us see what happens. So some solution like this. Let us see what solution we get for Q. So here also it is solve which we are using, but it is a SymPy solve. SymPy solve instead of NumPy solve or math solve. Print Z. I'm commenting this. I'm commenting this one also. So next part is just solve Z with x comma y. So it has not done that. By solve x comma y, it should give 0 0 or some value. Okay. Okay, let us go to the next one. I'll show you how to solve a system of equation in NumPy, which is more relevant for our problems because this is arbitrary function, so it doesn't give a solution. But for just x and y, it gives a solution actually. The 0 0 is the obvious solution, so it gives 0 0 as a solution. Yeah, it has given 0 0 as a solution. Otherwise, it couldn't compute the solution. So, then I'll comment this. We'll go to NumPy calculations. So in NumPy, I have given a matrix S1 is equal to a 3 cross 3 matrix. So as I told you, in NumPy it should be a small m. In SymPy it should be a capital M. Okay, and in SymPy you have a transpose in capital T, and in NumPy you have a transpose in small t. So here I mentioned S1 is equal to S2 is equal to S1 dot transpose. So in SymPy it is capital T which you have to do. So in NumPy it is small t. So if you take transpose of this, then you will get okay, we'll see what we can check that. S3 is equal to S1 plus S2, S4 is equal to S1 star S2. Then S5 I have given a column matrix. If you are giving a column matrix, then you need to just give single row. So here it is 3 cross 3. So 3 rows I have given, and in 3 rows, the first row has 3 elements representing 3 columns. Here it is first row with only one element, second row with only one element, third row with only one element, represent the columnar matrix. So now we'll see the first one. We can give anything for that matter. We can give S2, print S2, I give, we print S2. Let me clear the screen again because there are a lot of stuff here. So 2, 3, 3, 3, 1, 4 and 1, 2, 5 is a transpose of, yeah, it is a transpose of S1. Now I ask the system to compute S3. So S3 will be S1 plus S2. Obviously it should give a symmetric matrix. 4, 6, 4, 4, 6, 4, 6, 2, 6, 6, 2, 6 and 4, 6, 10, 4, 6, 10. So it's a symmetric matrix because S1 plus S1 transpose should be a symmetric matrix. Similarly, product of two matrices is computed. Now here I have used a square matrix. You can compute any M cross N and N cross P matrix that is computable. Next, we can check that, but I think it is obvious. I'll comment this print statement. I'll go to invert statement here. So invert will give the inverse of S4. So for that it is numpy dot invert. Inverse of S4 will be minus 15, minus 12, minus 24, minus 12, minus 15, minus 24, minus 24, minus 24, minus 51. And similarly, you have linear algebra computing the inverse. So let us check whether you get the same thing or not. That is because this is the inverse actually. Sorry, linear algebra inverse is the inverse of the matrix, and invert means it will. It should give a reciprocal of the matrix. I'll explain it to you some other time. Sorry, because I thought invert of the matrix should also give inverse, but I think it gives something else. But in linear algebra dot inverse will give you the inverse of the matrix. Similarly, linear algebra dot det will give you the determinant of the matrix. Determinant of the matrix. So 576.00001 or something, or 576 it would be. Similarly, trace of the matrix it computes. So you know what is trace? It is a summation of the principal diagonal elements of the matrix. So it computes that. 78. Then we'll just clear the screen so that we can get the eigenvalue and eigenvectors both together. It represents. It shows EIG is the command. Linear dot EIG is the command for eigenvalue and eigenvector. So I have given p print for that. So we'll get both. It's a 3 cross 3 matrix. So 3 linear 3 eigenvalues and 3 cross 3 vectors, 3 eigenvectors you get. So as I told, it is 7.3460917 3 and 2.65390983 and minus 4 is the first linear, minus 4, minus 4, minus 8, minus 7, 7, 4 and minus 5, 5, 5.6 into 10 to the power minus 1 and that's what 10 to the power minus. So we can change the problem also. We can give some other problem and check the exactness of the eigenvalues and eigenvectors. So that is, I change the problem to 201, 020 and 102. 01, 020 and 102. So So we need to find eigenvalue of S1, that is 312 is eigenvalue, root 2, 0, root 2 minus root 2, 0, root 2 and 0, 1, 0 are the eigenvectors. See, it is very easy to compute on Python. Next one is the solution, linear algebra solution for the equation Ax is equal to B. Here we don't give X, we just give A and B. That is, column matrix is S5, which we have taken 369, and S4, which is computed after S1 star S2, that is S1 plus S1 into S1 transpose. So let us see what solution we get. So it just solves Ax is equal to B, so X is equal to A inverse B. So you get the solution as minus 2.33333, 1.5, 3.666667 and so on. The next one will give you the singular value decomposition SVD of S4, some matrix. You need not give only capital letters for matrices, you can give small letters also, but usually if you give capital letters, it is best. Which I have not given, I am sorry. So this is the singular value decomposition of the matrix. Then you can find norm of a matrix, then even rank of a matrix. So let us see norm of a matrix. Norm of a matrix is 9.9, 9.899 something. And rank will be 0, 2, 1, 0, 2. Rank will be 3 for this matrix. Let us check whether it is 3 or what are my assumptions. Yeah, it is 3. Now, if I change the matrix to 0, 0, 1, 0, 0, 0. So, the matrix should give me the rank as 2, which we know it should as 1. 2 is the rank of the matrix. So this completes the first half of the session, wherein I have discussed till now about simple calculations using Python, especially the math library function, then polynomial SymPy function, and matrices NumPy function, usually linear algebra, which we have used. Now we'll go to the next session, that is on numerical methods. So as I told, we'll discuss about the first one is bisection method. So here I'll tell you how to write a function. So yeah. So as we know, we need to call a function first. We need to define a function for which we need the solution. So we write x cube minus 10 is the equation. So we are finding cube root of 10. So SymPy, you need to import symbol because x is a symbol which you are calling in f of x. Now again here you give an indentation. Once you declare, you need to return the function. The return value is simple. You have to give x cube minus 10. You can give print statement here, but you can give print statement here also. It doesn't matter. But again, you need not define function here. But if you are defining, then you can call the function in the console. So let us see. Let me clear the screen again. Okay. So now the equation is x cube minus 10, and we know bisection method, the main condition is that the solution should lie between the two endpoints. Now the criteria of finding out whether the solution lies between the endpoints is that f of a into f of b is greater than or equal to 0. If it is greater than 0, then you know that the solution doesn't lie between a and b because the sign doesn't change. And therefore you need to check whether f of a into f of b is less than 0. That's what we are doing here. If f of a into f of b is greater than 0, we see this f of a into f of b is less than 0, then we set the range I to 10,000. You can give lesser range also if the computation is small, but the lesser range will give you less accurate value. The more the range you give, the more accurate value you get. And I is ranging from 1 to 10,000. 1 lakh means, yeah, 1 lakh means it will compute 1 lakh times. So what computation it does is, C is equal to A plus B by 2. And again, it verifies whether f of A into f of C is less than 0. F of A into f of C is less than 0. And if f of A into f of C is less than 0, it will compute B is equal to C. Or else it gives A is equal to C, which is the usual technique what we do for bisection method. Let me compute this.
Madhukar sir,
Yes, sir.
again someone has disturbed the PPT sir.
Oh, okay, 1 minute. Yes, sir, this is happening today. Yesterday, I don't think this happened, no?
Yes sir.
Yes, sir. Thank you.
Sir.
So here, 1 to 1 lakh computation. So I have computed the value. Now you see the bisection. If I give any, we know the value of root 10. Root 10 lies between 2 and 3. Cube root 10, no? Cube root 10. Cube root of 8 is 2. Cube root of 27 is 3. So bisection method, it should give the value between 2 and 3. Now for suppose I give 0, 1. We have given the command that it doesn't lie there. So this of 0, 1, it should not give me the solution. So enter the correct A and B. That's what it is giving. Now this of 2, 3, if I give, you get the value 2.1544 thing, and it gives the error as minus 5.329 into 10 to the power minus 15. Okay. Similarly, we know regular falsy method. Regular falsy method, you need to verify the same thing, but only the formula changes. So if f of a star f of c, no, if c is equal to a plus b by 2, instead of c is equal to a plus b by 2, it will be f of b into a minus b into f of a divided by f of b minus f of a. So let us check that. Everything else is same there. Everything else is same. Now, whether it computes for transcendental function, obviously it should. So we'll give in pi dot b of x cube, okay, of x minus 10. What we get? Exponential function values 2 and 3. So x minus 10x I'll give. Then star x plus 3. Okay, we'll see what solution we get for this. Now it says this error because SymPy I am not called. I called from SymPy the symbol. So I'll import by. Okay. So now it has taken this. So let us check what we get. F5. So it has computed. So whenever you need to compute something, you need to run the program and then call the function in the console. That's all. So bits of, I don't know what range it will lie because exponential function is 2.7. 2.7 plus 3. I don't think the solution also should come. Let us see what we get. We'll give 0, 100. Between this interval, correct. So it doesn't come because it is not equal to 0 anyhow. So 2.7 minus 10 into whatever plus 3. So minus 10. So 2.75. So 5 means half. It should come half at least. So let us see. Let us check some value. Minus 1, 0. Enter correct value. This minus 10, 0. So I don't think the solution is for this, but you can give some other value. Exponential of 2 star, I'll give 2 star. SymPy exponential of x minus 10x plus 3. So here this of minus 10, 10. Suppose I give this A and B. No, it doesn't. But it does solve the problem. I can give some other problem where we know the solution. So I think usual textbook problem would be SymPy dot log. log comma simpy dot e of 1 minus 1.2, no? Log e x minus 1.2 equal to 0. I think that has a solution. So let me write 1.2. Okay, so whether this has a solution or not, we'll just check. So it runs, so no problem with the code. Only the range is a problem. It's of 1, 2. Invalid comparison of log. Because log 0 is there, we'll exclude 0 and log 0 cannot come anyhow. 1, 1,000. It is computing, it is taking time, but it will compute and give the solution. So yeah, it has given the solution as 3.320169 as a root of the equation with the error as 2.22 into 10 to the power minus 6. So in order to solve transcendental and algebraic equation of higher order, we need to do such techniques. So we'll go to Range, sorry, not Range, but it is regular falsy. Regular falsy method. As I told, C is equal to only the, yeah, only that changes. So here we have given written x minus 1 into x minus 2 into x minus 5. So it's a cubic equation. Range we have given minus 10 to 10, and f of a is less than f of a into f of b is less than 0. So again, C is equal to a f of b minus b f of a divided by f of b minus f of a. So it checks this, and here the function is regular falsy. So we need to call the function again. I have not declared any variable here because already we have taken a and b. A and b is in the range minus 10 to 10. So it needs to find the solution. Let us check what happens. So it has computed regular falsy dot py. I'll clear the screen. Give reg fol. This is computing. So it should give one of the solution as 1 or 2 or 5. Some solution it should give. Yeah, 5 is the root of the solution and error is 0. Okay. So you change the equation to anything. For example, e bar x minus 1. So x is equal to 0 we need to get. E bar x minus 1 into. So e bar x is not there, so we need to call simpy dot e bar x. So we need to remember this part because whenever we don't declare some function, we need to call it with the library. So import simpy. Again, we check this. Since we have written a function, we need to call the function again. I think x is equal to 0. It will give one of the solutions. So let us check what we get. Now my system is slow. I'm sorry for that. That's why it is computing very slowly. Otherwise, if you have a faster system, then it does faster. 4 GB RAM. So that, though it is good enough, but still it is not very good for Python. Because I have other softwares also which are installed in my system, so compute slowly. We'll discuss with about the next Newton absence method. We know that f dash should be required here. Newton-Raphson, Newton dot I. So df of a is given to us. Otherwise also you can find df of a, but only thing is it will compute it as a string. Now we cannot, we need to convert it with a different function, so that becomes a bit complicated. For our small purposes, we can go ahead with this. F of x is equal to x cube minus 10. df of x is equal to 3x square. So Newton A. So give some variable, some value A for which you need to compute this, compute the solution. The initial condition, initial solution would be the trial solution would be A, and finally it gives back A as the solution after computing 1 lakh times. It's taking a lot of time. If you don't mind, I'll truncate this. Whenever you want to truncate it, you need to click on this red button which is there, stop the current command. So if you do that, it truncates and it comes out, or you can press Control C. Control C, if you press, it comes out of the. Once it comes out of the loop, you can. Now, if you want to decrease the loop, you can do that. Instead of 10,000, we can give 100 or something. 100, and we'll see what. It should compute faster. The reason it takes time is because it has to compute for all the values between -10 to 10, and then it needs to check for f of a into f of c, so it takes time. You can also do fixed point iteration, which I have not discussed here. So we have taken Newton-Raphson's, but fixed point iteration, you just have to take f of x is equal to x, or if you have given x, f of x is equal to some value, x cube minus 10, then you need to write it as something like a minus f of a by df of a, which gives you some g of x for g of a for a. And since Newton-Raphson's is one of the fixed point iteration, so it's better to go with Newton-Raphson's itself and then find the solution. I'm sorry, this is really taking time. I'll truncate this. I'll go to the next one, Newton-Raphson's. So Newton of, we know x cube minus, so you can either start with 2 or 3 or any other value also, because here there is no restriction of f of a into f of b. So suppose I take Newton of 1. So I didn't run the program, sorry. Newton of 1. 2.1544, and error is 1.7763 into 10 to the power minus 15. So let's now go to linear algebra part, wherein I'll discuss about 3 things as mentioned: Gauss-Seidel, Gauss-Jacobi iteration, and power method to find the largest eigenvalue. Let me close these. Gauss-Seidel. Yeah. So here Gauss Seidel we have used this triangular matrix. Okay, lower triangular of an array. So you see here NP dot lower triangular of an array which we are considering. And upper triangular is A minus L, which we know. The LU decomposition will give L plus U is equal to A. So I is in range N. N is, if we give A and B, if we give, I think it is already given here. A is this matrix, 3 cross 3 matrix, and B is 3 cross 1 matrix, and X is the initial value 1, 1, 1, and N is number of iterations 20. Then you solve for A and B. First you represent the matrix and then use linear algebra solver and then write solve A, B. Then you get the solution. So you are finding out. So it starts with 0.5, 1.667, 0.52, and then finally it ends up with two consecutive values being same, 0.04, 0.2, minus 0.2, and 0.5. There's another way of doing this also, but you have to be specific for what you are doing. Say, for example, you can here in this problem you can increase A to any n cross n matrix. But suppose you want to write it by yourself, then you need to call for loops and then do it, which we do usually for in C and so on, in C and other programming language. So this is Gauss Seidel, and you know what Gauss Seidel does? You take the base vectors and it finds out. So for example, here you start with 0.5 here. This 0.5 is substituted for the second equation, and these two are substituted in the third equation, and so on. So that's what we get. Jacobi iteration is slightly different. So here you represent the matrix like this, and you saw the matrix here. And Jacobi iteration also. Jacobi iteration. Yeah. So here again you have A matrix. So this is basically a matrix of diagonal dominance. Okay. And B is 16, 17, 18. So initial value is 0, 0, 0. Then 250 values it is computing. Rest all is similar to this one. Only thing is, instead of A minus lower triangular matrix, you are considering the diagonal element of A, NP dot diag, and diagonal element of A, and then you are computing it with respect to that dotted with X and X. Let me run this. So 1, 1, 1 is the solution. I think that is correct. 14 minus 14 plus 1 is 16. 15 plus 1 is 17, and so on. So power method. So there are two programs which we have done. Let me discuss this. So here we have taken. We need to find the largest eigenvalue. So we know the method. The method itself is written in this way. That is, you start off with B is equal to X. X is equal to 1, 0, 0, base vector 1, 0, 0, 0, 1, 0, 0, 0, 1, or anything 1, 1, 1, and so on. Then find eigenvalue is equal to np dot linearis dot norm of B. Then x nu is equal to B by eigenvalue. So if this value goes less than 0.001, then print it. Otherwise, break. Otherwise, go x is equal to x nu and then continue the loop. That's what it says. Up to 100 values it needs to compute on the program. 14.560 is the eigenvalue for this particular problem. And the corresponding eigenvector can be given, provided we just have to write B, value B, print x and B. Reprint here. Print comes only in simple. Print eigenvalue, print x nu. I think it is printing only the print eigenvalue. It is only the eigenvalue. Comma p. Suppose I get this. P value is minus 414,000,000. Let us see the other power method. Yeah, here we are not using norm, but instead we are using the same logic. D is equal to max of absolute value of C, because even if it takes a negative value, we take the positive of that. So we take the absolute value of that, and then we print this power method. AB is given, so return 0. Yeah, so let me run this. And we need to call the function because it's a function here. Other one was a script. So you get the eigenvalue and eigenvector. The corresponding eigenvector is 0.661 and 0.63, and eigenvalue is 6.85. Now we'll go to interpolation. I think we discussed polynomial techniques in numerical methods, and we discussed matrices numerical methods. The final one which is there for today's topic is interpolation. So there are two interpolation techniques which I'll be discussing. One is Lagrange, another one is Newton divided, and cubic spline. Lagrange can be done directly. So let me deal with Lagrange and cubic spline because it's just a direct command from SciPy. So this is scientific Python. Yeah, scientific Python package, and in that we have interpolate another class or module, and we call it a scient, give an alias name for that. We call in the two arrays. Now we have to be careful for Lagrange. It takes maximum of 20 values only, and beyond that it doesn't take. So we have to be careful of the interpolation. And here this is spline representation of 1D curve, and here by default k is equal to 3. You can represent k is equal to whatever you want depending upon the spline which you want to do. So here it's a cubic spline which I have given here. So we can print both. One, let me print T first. That is Lagrange. So you get the equation 0.0466688 x cube minus 0.6406 x square plus 3.553x minus 0.8594. Here we can substitute the values. You can write subs here and then get the values of x. For what values of x you need the interpolation, you can do that. And the second one is only problem is this is a string and you need to convert it to a floating point value. Second one is cubic spline. This gives you the interpolation values. The array itself it gives. So you get it as 1, 1, 1, 1, 11, between 1, 1 and 11, 11. So what are next we'll go to Newton absence. Oh, sorry, Newton forward and backward interpolation. Newton forward and backward interpolation. Newton forward. Yeah. So here I've taken equally spaced data and so AI minus 1. This is what we do for I is equal to 1 to n and the backward way n minus 1 j minus 1 minus 1. So if you run this program, and I'm here, if you see, we are finding out the value for 1.23. 1.23 is here, so it should do the forward interpolation. So it's the same program for forward and backward because the table is same for forward and backward. Only for divided difference it will be different, and the divided difference will be using xi minus j here. That's all. That's the only difference here. 23.3, which should be 2, and if you change this to 6.23, you are supposed to get somewhere around 71 and 81. If you do that, sorry, 6.23, and you're supposed to get 73.3. So somewhere between 71 and 81. Finally, we compute Newton interpolation. Newton interpolation, that is divided difference. As I told you, the only difference is xi minus j. J ranging between 1 to n. So it computes xi minus 1 because I ranges between ni minus 1 to ji minus 1. So you get delta y by delta x. So it's uneven distributed data. So here I'm computing it for 1.2. If you run this, you get 3.636744. So I think I'll conclude today. Tomorrow we'll take up numerical methods, differentiation, integration, limits, continuity concept. And I would like to answer yesterday's question. You need to use network X. You need to use network X for doing graph theory problems. So we'll show that in the last day, that is network X is the library for graph theory problems, and trees can be called there. Then you can compute minimal spanning tree, Dijkstra algorithm, and so on. All those things you can do using network X. Yeah. Yes, sir.
Yes, sir. Yes, sir. We have a few questions, sir.
We'll conclude today. Yeah. We'll take
We'll conclude, sir. We'll conclude. We have a few questions. One by one we'll take.
Yeah, sure, sir.
Thank you, sir. First question.
Yes, sir. Yes, ma'am.
Can we work on Jupyter? Functions will be same, from Ganesh.
Jupyter functions will be same, but only thing is you have to write it in terms of a HTML page, and it is not very easy as in terms of Spider. Spider you can compile it in usual way, but there after compilation you need to write it in terms of HTML page. It is not a compiler, I think. It is just a representation of the data.
Okay, sir. Thank you. One more from Sunil Pati. How to get the elements in the matrix in fractions rather than decimals?
Okay, you want the matrix elements should be in terms of fractions.
No, sir, in decimals rather than yes, sir.
In fractions, yeah, that's what. 1 by 2, 1 by 3, and so on. Even if you give it, computes in terms of fraction only. What is a utility? Only thing is the representation for students will be like if you want to do irrational number and so on, 1 by root 2, 1 by root 3, and so on. Then you can do that. But otherwise, it converts it back to decimal point only.
Okay, sir. One more from Ganesh sir only. Can we solve numerical methods using NumPy, NYMPY?
Yeah, numerical methods only we did using NumPy. NumPy, basically NumPy will have numerical routines only. But if you want to write program, we can use numerical methods and the numerical NumPy, and then we can write our programs and compute it.
Okay, sir. From Yogita, are there any inbuilt functions for fractions?
For fractions, actually, two questions came like this. No, one for matrix fraction and this one.
I mean,
need to check
fractional order differential equations. Are there inbuilt commands to solve fractional order differential equations?
I have not checked, ma'am, because I have not dealt with fractional differential equations. So, but we can check that tomorrow when we see. We can put 0.5 and or 0.3 and so on, and then check whether it solves a differential equation. There are ODE solvers, but they do it for linear equations. I don't think it is possible for fractional. Let us check it tomorrow when we do it for differential equations.
Yes, sir. Thank you. And last one from Pramod. Yes. Sir, can you show the power series expansion summation where both AI and f of xi are still unknown if possible, he is asking.
Whether they are unknown, I need to check. But if tomorrow we'll be seeing the Taylor series and Maclaurin series, if possible, I'll try to include power series also, so that we'll see whether it is possible. But complex analysis part, till now I have not tried much. But only thing is, you can solve CR equations, you can solve Milne-Thompson's and so on. But this part I have not checked. Let me see that. I'll get back to you tomorrow.
Okay, sir. Sir, one more last question. For beginners, could you please suggest how to learn Python?
Okay, yesterday, the day before yesterday, sir told one method. There are so many repositories like GitHub. Like for example, today 2 which I gave was from GitHub. One is numerical, this one, Newton's divided difference and power difference. These two were from GitHub programming repository. Another one was Kaggle. Kaggle is another thing. They give the programs. If you know other programming languages, you can directly learn them from them. Otherwise, you need to start off with a good book. I will suggest the book on last day. For mathematics itself, there is a book called programming using Python for mathematics and statistics. So if you use that book, you can do a lot of works on Python. So I'll suggest that book in the last.
Thank you, sir, for your all answers. Thank you very much.
Thank you.
Yes, sir. Thank you so much, Sir Madhukar, sir, for a wonderful session, for giving a detailed idea on basic fundamental calculations, then matrix evaluations, and finally with the numerical methods, various methods in the numerical techniques, etc. So thank you so much. So we'll be concluding today. We'll start sessions with tomorrow at 10 a.m. sir.
10 a.m. Yes, sir. Yes, sir. Thank you, sir.
Thank you so much, sir. All participants are requested to fill the feedback within 1 p.m. Tomorrow we'll continue with our session at 10 a.m. Thank you. Thank you so much for your cooperation.